Imagine this. The year is 2500. Humanity has finally built a probe capable of leaving the Milky Way. Billions of people across countless worlds are watching the live feed as Wanderlust 1 crosses the edge of our galaxy, heading toward Andromeda. This is it, the moment we become an intergalactic species, and then without warning, the probe crumples. The entire middle section folds in on itself like paper. Metal distorts, buckles, tears apart, parts of it simply vanish. The probe starts spinning wildly through the void, all systems dead, transmission lost. What just happened? A primordial black hole, invisible, microscopic, but with the mass of a full-grown rhinoceros. And it just obliterated our billion-dollar spacecraft in a fraction of a second. Now, I know what you're thinking. That's science fiction, right? Well, here's where things get disturbing. The James Webb Space Telescope may have just found evidence that these tiny black hole monsters are real, and they might be surrounding our entire galaxy right now. Welcome back to the Curiosity Beast, where we chase down the mysteries that scientists are afraid to talk about. I'm diving into one of the most unsettling discoveries in modern astronomy: primordial black holes. What are they? How did the universe create them? And here's the terrifying part. Could they be the invisible prison bars keeping humanity trapped in the Milky Way forever? Let's go deep. For decades, scientists thought they had black holes figured out. There was only one way to make them. A massive star, at least 20 times heavier than our sun, runs out of fuel and explodes in a supernova. The core collapses under its own gravity, creating something so dense that not even light can escape. That's your classic stellar black hole. But here's the problem. Stellar black holes have limits. They can't be bigger than the biggest stars, maybe a few hundred times the mass of our sun. And they can't be smaller than about 3 solar masses, because anything less doesn't have enough gravitational power to collapse into a black hole. You'd get a neutron star instead. So if black holes can only form from dying stars, and stars have size limits, then black holes should have size limits too. Simple, right? Wrong. Because then we discovered supermassive black holes, monsters at the centers of galaxies that weigh millions, sometimes billions of times more than our sun. These things shouldn't exist according to what we knew. There's no star big enough to create them. And for a while, scientists tried to explain it away by saying, well, maybe small black holes just ate and ate and ate until they became giants. But that theory started falling apart when we looked deeper into space. And this is where the James Webb Space Telescope completely changed everything. When JWST turned on in 2022, it gave us something unprecedented: the ability to see galaxies from the earliest moments of the universe, just 500 million years after the Big Bang. And what did it find? Supermassive black holes. Everywhere. In tiny baby galaxies that shouldn't have had time to grow them. Here's why that's a massive problem. If black holes grow by consuming matter, they can only eat so fast. There are physical limits to how quickly they can pull in gas and stars. And when we do the math, these ancient supermassive black holes didn't have enough time to grow that big. Not unless they were breaking the laws of physics. So where did they come from? Some scientists think they found a loophole, that these black holes were somehow eating faster than they should. But a lot of astronomers aren't buying it. And that's when an older, darker theory started getting serious attention. What if some black holes didn't come from stars at all? What if they were born in the first second after the Big Bang? Let me take you back. 13.8 billion years ago. The universe has just exploded into existence. It's unimaginably hot, unimaginably dense, a boiling soup of particles crashing into each other at impossible speeds. And in that chaos, matter wasn't spread out evenly. There were spots where it clumped together, where the density was just a little bit higher. And in those spots, something incredible could have happened. The pressure could have been so intense that matter collapsed directly into black holes. No star required, no supernova needed, just pure gravitational collapse in the first fraction of a second after creation. These are called primordial black holes. Now, this isn't a new idea. Soviet scientists Yakov Zeldovich and Igor Novikov predicted them back in 1966. But for a long time, nobody took them seriously. Here's the thing. Primordial black holes could have formed in any size. Some might have been massive, 100,000 times the mass of the sun, which would perfectly explain where supermassive black holes came from. But others could have been tiny. We're talking black holes the size of an atom, with the mass of an asteroid, or even smaller. Black holes no bigger than a proton, but with the mass of a rhinoceros. Think about that for a second. An object smaller than the width of a human hair, invisible to every instrument we have, but heavy enough to crush a spacecraft into scrap metal in an instant. That's a black hole rhino, and the universe might have created trillions of them. And here's where it gets controversial. If tiny black holes formed back then, they should all be gone by now, because of something called Hawking radiation. Stephen Hawking figured out that black holes aren't completely black. They leak energy very, very slowly. And over billions of years, tiny black holes should evaporate completely. So even if they existed at the dawn of time, they wouldn't exist now. Case closed, right? Not so fast. Drop a comment right now. Do you think tiny black holes are still out there lurking in the darkness? Or did they all evaporate billions of years ago? I'm genuinely curious what you think. In July 2024, NASA dropped a bombshell. The James Webb Space Telescope spotted something that shouldn't exist. Two early galaxies, likely colliding with each other, but floating between them, not inside either galaxy, was a supermassive black hole. This black hole wasn't in the center of a galaxy where it should be. It wasn't orbiting anything. It was just there, hanging in space like it materialized out of nowhere. And both galaxies already had their own supermassive black holes, so it couldn't have been ejected from one of them. The team who discovered it had only one explanation. This black hole formed out of nothing. It collapsed directly from a cloud of gas, just like primordial black hole theory predicts. No star died to create it, it just appeared. But wait, there's more. Another black hole called QS01 was also found by Webb. This one lives in a surprisingly small galaxy, and when scientists analyzed its light, they found something shocking. The galaxy had almost no heavy elements, no oxygen, no carbon, barely any metals at all. Less than 1% of what we see in the Milky Way. You know what produces heavy elements? Stars. When stars explode, they scatter metals across the galaxy, but this galaxy had almost none, which means very few stars had formed there yet. So where did the black hole come from? If stars create heavy elements, and this galaxy has no heavy elements, then the black hole couldn't have come from a star. It had to have formed some other way. Now, these discoveries aren't definitive proof, but they're the strongest evidence we've ever had that primordial black holes are real. And if supermassive primordial black holes exist, then the tiny ones probably did too. But they all evaporated, right? Maybe not. Let's talk about dark matter. Astronomy has a massive problem. When we measure the gravitational pull inside galaxies, there's way more gravity than there should be. Galaxies are spinning too fast. There's not enough visible matter to hold them together. So scientists came up with an explanation. There must be invisible matter we can't see. They called it dark matter. But here's the uncomfortable question. What if dark matter isn't some exotic particle? What if it's just black holes? Primordial black holes, millions or billions of them, surrounding every galaxy like an invisible swarm. Now scientists have looked for large black holes circling the Milky Way, and they're not there. If they were, we'd see stars getting flung around. We'd also see gravitational lensing, where light from distant stars gets bent and distorted. We don't see that. But tiny black holes? Black hole rhinos? Those would be almost impossible to detect. They're too small to cause noticeable gravitational lensing. They wouldn't fling stars around. They just drift through space, undetectable. And here's the kicker. In April 2024, a study found that Hawking radiation might not work the way we thought. At tiny scales, the radiation might slow down. A lot, to the point where these black holes stop shrinking entirely, which means they could still be out there, right now. Millions of them, billions of them, surrounding our galaxy in a massive invisible halo. A minefield of microscopic black holes, each one carrying the mass of a rhinoceros, drifting silently through the void. And we'd have no idea. If you're still watching, make sure you hit that subscribe button. The Curiosity Bee's all about uncovering the truths that make you question reality. Think about that. If this theory is true, then every time we send a probe into deep space, we're playing cosmic roulette. One collision with a black hole rhino, and it's over. The probe crumples, the mission fails, and we'd probably never even know what hit it. Now, some of you might be thinking, okay, but space is huge. What are the odds of actually hitting one? And that's fair. Space is incomprehensibly vast. The chances of a random collision are incredibly low. But here's what keeps me up at night. If dark matter is actually a swarm of primordial black holes, then they're not randomly scattered. They're concentrated around galaxies, which means the further out we go, the more of them we'd encounter. And if humanity ever tries to leave the Milky Way, if we ever attempt to reach Andromeda, we'd have to pass through the densest part of that halo. We could be surrounded by an invisible cage, and we wouldn't even know it until we tried to leave, until our ships start disappearing, until probes stop transmitting, until we realize that the universe put up a barrier we never saw coming. That's the truly terrifying possibility here. Not black holes exist. We've known that for decades. But that there could be billions of invisible ones, too small to see, too numerous to avoid, forming an impenetrable barrier around our galaxy. A cosmic prison that we won't discover until it's too late. Now let's address the elephant in the room. Or should I say, the rhino in space. If these black holes exist, could one hit Earth? The short answer is probably not. Space is enormous, and even if there are billions of primordial black holes out there, the odds of one passing through our solar system are astronomically low. But, and this is a big but, it's not impossible. If a black hole rhino did pass near Earth, what would happen? Well, it depends on how close it got. If it passed through the atmosphere, it would create a shock wave, maybe trigger some atmospheric disturbances. If it hit the ground, it wouldn't explode like a meteor. It would punch straight through the planet and come out the other side, leaving a narrow tunnel of destruction in its wake. But here's the really creepy part. If it passed through you, you wouldn't even see it coming. One moment you'd be standing there. The next, you'd have a microscopic hole running straight through your body. You'd probably be dead before your brain even registered what happened. No warning, no defense, just instant obliteration from an invisible threat you never knew existed. Is that likely? No. Is it possible? Technically, yes. And that's what makes this theory so deeply unsettling. So where does this leave us? Are primordial black holes real? Are they lurking out there in the darkness? Are we trapped in our galaxy by an invisible swarm we never detected? Honestly, we don't know yet. The evidence is mounting, but it's not conclusive. The James Webb discoveries are fascinating, but they're not smoking guns. The dark matter theory is compelling, but it's far from proven. And the idea that Hawking radiation slows down at small scales is still being debated. But here's what we do know. The universe is stranger than we ever imagined. The rules we thought were set in stone keep getting rewritten. And every time we look deeper into space, we find something that challenges everything we thought we understood. Primordial black holes might be real. They might be surrounding us right now. And if they are, then humanity's dream of exploring beyond the Milky Way just got a whole lot more complicated. We might need to invent entirely new technologies just to detect them, let alone avoid them. Or maybe this is one mystery the universe will keep hidden until the day we try to leave and find out the hard way. So, what do you think? Are we trapped in an invisible cage of primordial black holes? Or is this just another wild theory? Drop your thoughts in the comments. I want to hear what the Curiosity Beast community thinks. And if you're still watching, comment Black Hole Rhino so I know you made it to the end. The Curiosity Beast is all about exploring the unknown, questioning the accepted, and diving into the mysteries that keep us up at night. If you love this kind of content, subscribe, hit the bell, and join the community of curious minds who refuse to accept easy answers. Because out there in the darkness, the universe is hiding secrets, and we're going to find them. Thanks for watching. Stay curious, and I'll see you in the next one.